Welcome to the classroom. Today we're talking about igneous rocks. Igneous rocks are formed either underground and you get really big crystals, or above ground in like volcanic eruptions. And the magma that is extruded on the Earth's surface, called lava, when it gets up there, is cooled really quickly, so the crystals are small. Usually we have three common minerals: quartz, potassium feldspar, and then plagioclase, which could have sodium end member or calcium end member. And that gives us the dominant colors that we see in our rock. Usually quartz is a white to grayish mineral. Potassium and sodium plagioclase go from white to black. And then we have our potassium feldspar, which gives us our nice reddish pink colors in our granitic rocks. And so those minerals are quite common, but we have other minerals as well. So in the field, what we're looking for are those crystals of minerals that we can identify. If it's an extruded igneous rock out formed on the surface, the minerals may be too small to identify and we'd have to use other factors, but when it has cooled underground, we have large crystals, we can identify them even without our hand lens in some cases. So this boulder here I have, it's not what we call bedrock, it's a boulder. It probably was placed here by the glaciers or brought in just as a decorative stone along the pathway. But we can see we have light and dark minerals, okay? There's a lot of black and a lot of white minerals. And that sort of salt and pepper look is what we call a diorite. I don't see a lot of red minerals present here. We could have a few percent potassium feldspar and still be, still considered a granite. You'll have to look at the ternary diagram to classify your granitic rocks. But in this sample, we can very quickly see large crystals of the black mineral. Those are probably our plagioclases, and we can see even in some cases the shape. We want to have our plagioclase have that rhombohedral shape, okay? And I've got a sample in my backpack. We'll have a closer look. All right, this is some quartz from Big Gull Lake, just north of Kingston. And it came from a vein in the igneous rocks there. But you can see this 1, 2, 3, 4, 5-sided shape right there, okay? That's like a quartz crystal that's been cut along this plane. That's very typical quartz shape, all right, in cross section. So this is a vein of quartz crystals. They're really coarse grained. They grew into the void space that was an opening in the rock. But you can see some of that kind of cross-sectional shape, and that's what you got to look for when you are looking for your igneous rocks. Okay, this is actually a piece of countertop that washed up on the shores of Lake Ontario. It's actually got a lot of labradorite in it, and the labradorite is a special kind of plagioclase, in fact, or feldspar. And so it's a bit hard to see here, but you can see a crystal there of that sort of rhombohedral shape. But when I wet it, it'll probably show up a little bit better. So there you have it. When I wet it, you can really see that plagioclase's sheen on it when it's wet. So that's what the main thing we're going to be looking for in our igneous rocks. We want to see those coarse grained minerals, okay? The crystals, they're different than coarse grained fragments in our sedimentary rocks. Our sedimentary rocks, the grains are going to be more rounded, and it'll kind of look a little bit like sugar almost, and kind of compressed together in our coarse sedimentary rocks. In our igneous rocks, they're going to be very close fitting, like puzzle pieces, minerals, and they can see their crystal shape. If we were to smooth this out, saw it in half, you could see really crystal shapes, and that is indicative of an igneous rock that is cooled underground. We could see those crystals. And those fine-grained igneous rocks, we'd have to look at thin sections. Maybe in certain parts you could see evidence of larger crystals that got caught up in, they formed deep underground and they got caught up in the magma that was extruded on the surface and then cooled. So there are other things that we can look for in our extruded igneous rocks. But more commonly, we can easily identify our intrusive igneous rocks in the field. So stay tuned for more videos, and like and subscribe for the channel. And I hope you like to learn about igneous rocks, and you'll see more videos on the channel in the future. Thanks for watching.